Hello everyone. Before we start, let me introduce. My name is Alvin from class 802, a student number 3. Today, I with my partner are going to discuss about page number 6, about the evolution of the photography in astronomy.
Hello everyone, my name is Amanda from class 802, student number 4, and let's start our conversation.
So, look at the page. It's fascinating for how astronomers used to relate so highly on direct photography using the gas plate. Did you find any specific advantage of using those plate, Amanda?
Yes, Alvin, the text mentioned that glass plates are great because they don't bend, they can be measured very accurately, and they preserve information over a long period of time for future astronomers to examine.
That's true, but it's also point out of a major limitation. Even with long time exposure, this sensitive plate only convert a small percent of proton into an image.
Exactly, which means photographer isn't very efficient for short time exposure, but despite that inefficiency, why do you think it remained usable for so long?
Well, according to Page, it's worked as a two-dimensional detector that covers a massive area at the telescope focus. So a single photograph can actually hold an enormous amount of information.
I see, especially when the photographer is familiar or skilled with wide field telescopes, right?
Briefly, but then the text shift to the modern times. How has technology changed the way astronomers view space today?
Today, newer radio and X-ray telescopes allow them to view images that are completely invisible to the human eye. Because of this, traditional direct photography is used much less often now.
Right. Instead of looking at old glass plate, modern astronomers can just study a advanced view right on a television monitor.
Yeah, and what happened to that data after they view it on the monitor? Does the computer play a role?
Yes, it's in most cases the data is converted by a computer in digital form. The text called this entire procedure imaging processing.
Image processing. The passage notes that it plays a central role in astronomy today. It makes sense because digital data is so much easier to analyze and share.
Definitely. The last paragraph has also mentioned something really cool that's called false colors. Do you understand what that means, Amanda?
Yeah, I think so. The colors are false because they around the actual colors of the object in our visual range of the spectrum. They are basically codes generated by the computer.
Oh, so the computer used the false colors to display information that would otherwise the complete undetectable to our unaided eyes.
Spot on. For example, the text says these colors can be used as codes to represent specific properties like X-ray emissions coming from stars.
That's incredible. It means that a star might look blue or red in digital image, but because but it's not because it actually it, but to show how strong its X-ray radiation is.
Yeah, exactly. It's all about translating invisible data into something visual that scientists can actually study and map out.
It's amazing to see the jump of waiting hour to of light to hit a glass plate to instantly processing X-ray digitally.
Yeah, I agree. Technology has completely transformed astronomy from a passive recording science into a highly dynamic digital field.
Do you think the old glass plates are completely useless now, or do you think still hold some historical value?
Yeah, the text says they preserve information over a long period, so they are probably still useful for comparing how the sky looked decades ago versus today.
Good point. Long-term records are crucial to supporting change in space over time.
True, but modern digital storage definitely takes up a lot less physical space than thousands of large glass plates.
Absolutely. Imagine moving Imagine moving a room full of fragile glass plate comparing to just saving file on a hard drive or cloud storage.
Yeah, and digital image processing also allows astronomers to zoom in and manipulate the data instantly without damaging the original file.
Yes, the flexibilities of digital tools combined with radio and X-ray data give us a more complete digital picture of the universe.
It really does. It shows that what we can see with our eyes is just a tiny fraction of what's actually out there.
Well, the page gives us a really clear breakdown of the technologies chief. I think we covered all of the key points.
Yeah, I think so too. This was a great discussion, Alvin. Thank you for your insight.
Well, everyone, we have reached the end of our discussion about the evolution of photography in astronomy. We learned how technology has changed astronomy from traditional glass plate to modern digital imaging processing.
Yes, and we also learned that modern technology allows astronomers to study parts of space that cannot be seen by the human eye, such as radio waves and X rays.
We hope this discussion has helped you to understand how important technologically advancements are in the field of astronomy.
Yeah, thank you very much for listening to our discussion. We hope you enjoy it and learn something new today. Thank you
Thank
and
you and
have a great
have a
day.
great day.